Hello students of standard 9. Now we will solve question number 3 and question number 4 from practice set 5.5. Question number 3 is, in the figure triangle ABC is an equilateral triangle. Points F, D and E are midpoints of side AB, side BC, side AC respectively. Show that triangle FED is an equilateral triangle. See this figure, triangle ABC is given, F is midpoint of AB, D is midpoint of BC, E is midpoint of AC. Now triangle ABC is equilateral triangle, it is given, we have to prove triangle FED. This inside triangle is an equilateral triangle. Solution, in triangle ABC, F and E are midpoints of sides AB and AC respectively. Therefore, by midpoint theorem, this FE is half of BC. FE is equal to half of BC, number 1. Then, in the same triangle, D and E are midpoints of side BC and AC respectively. Again, by using midpoint theorem, DE is half of AB. Then, D and F are midpoints of side BC and AB respectively. Then, DF is half of AC. Again, reason by midpoint theorem. Give it number 3. Now, observe 1, 2 and 3. Now here in 1, FE, in the figure you see, FE is half of BC, then FD is half of AC and DE is half of AB. Then triangle ABC is an equilateral triangle, means its all sides are congruent. Therefore BC is equal to AB is equal to AC. Now multiplying each term by half. Therefore half of BC is equal to half of AB plus half of AC. But from 1, 2, 3, half BC is FE, half AB is DE and half AC is DF. Therefore FE is equal to DE is equal to DF. Means all these three sides of triangle DF are equal. Means triangle DF is an equilateral triangle. Now question number 4. In the figure, sec PD is a median of triangle PQR. Point T is midpoint of sec PD. Produce QT intersects PD PR at M. Show that PM upon PR is equal to 1 upon 3. Hint is, draw DN parallel to QM. Now see figure, triangle PQR is given, D is midpoint of QR, then PD is median and T is midpoint of PD. Then we have to draw one segment DN which is parallel to QM. This is construction. Now solution, draw sec DN parallel to sec QM such that P dash M dash N and M dash N dash R. In triangle PDN, see here triangle PDN. Here T is midpoint of sec PD and TM is parallel to sec DN. I am showing you in triangle PDN. T is the midpoint and TM is parallel to DN. So by converse of midpoint theorem, this TM bisect third side PN. Therefore, by converse of midpoint theorem, M is the midpoint of sec PN. Therefore, PM is equal to PN, number 1. Then in triangle QRM, D is midpoint of sec QR. Now see where is triangle QRM. QRM. Here D is midpoint and line passing through D, DN is parallel to QM. Again by converse of midpoint theorem, line passing through midpoint of one side and parallel to second side bisect third side. Therefore, N is midpoint of MR. See here, by converse, N is midpoint of MR. Therefore, MN is equal to NR, number 2. Now observe 1 and 2. PM is equal to MN and MN is equal to NR. Therefore, PM is equal to MN is equal to NR from 1 and 2. Give it number 3. Now from figure, PR is equal to PM plus MN plus NR. See in this figure, PR is equal to PM plus MN plus NR. Now from 3, all these 3 are equal. So replace MN and NR by PM. So therefore PR is equal to PM plus PM plus PM means 3 PM. Now shift PM to that side, let LHS. It becomes PR upon PM is equal to 3. But 3 upon nothing is there means we can take 1. 3 upon 1. Then take inverse of both sides. Therefore PM upon PR is equal to 1 upon 3 is proved. Write these examples in your maths notebook.